Welcome to another episode and video on my Raspberry Pi 1 running Raspbian Linux, and equipped with a Serial Pi Plus board stacked upon the Raspberry Pi, which connects serially to Minicom serial terminal on the laptop. Also through the Serial Pi Plus goes the cable for the Raspberry Pi cam, or RaspberryCam, which is considered as the red LED shows is running. Also connected is network cable, which is connecting for VNC, virtual network computing, and the band cable connected to GPIO, which connects then to this breadboard. And I have to adjust a little bit more. So this breadboard is filled with two things. This part I'm not using right now. So focusing on this part, which is the MCP 23008 I2C extension to the Raspberry Pi, and electronics and fischertechnik. So this is an extra LED. I could have used 8 LEDs right here, but it's a bit well, not ideally positioned, so I use this one. And this LED is connected straight to the GPIO with switch, so when the software runs and I press the switch, this LED starts working. Last time I had a problem that it didn't work, although all signals were there, and through I2C I can measure the signals, but that doesn't mean anything if this doesn't work. So I connected two probes, the remaining two probes for the oscilloscope here, and I changed the program a bit so it didn't take as long, and then it turns out it did work. Will it go the same way? Will I see that indeed the bit counts? Because this is all binary, and this is a binary means 0 or 1, no other digits. So this is 0 or 1, and this is 2 or 3. So in total you can make 4 digits, which is 0, 1, 2 and 3 together. Will this work? Not sure, and if this works I'm going to extend it again to maximum of 7, which including 0 means 8 digits. And by taking not the full length of all 8 bits, it should be clear that if it works, it goes from 0 to 8 and from 8 back to 0. So let's see if that works out. I'm quite curious. So starting the program right now. And yes, it does work. Well, the LEDs work, so that's great. Does this one work? Actually, not really. So is there a problem right here? I need to check out. Yes, there is a problem right there. because this wire has gone out, and let me remove this wire for now. So this wire should be either here or on the other side, and now this wire becomes a bit, well, let's say not very convenient in locating. And this is 4, so this should be in 5 here. So that location is good. But this doesn't work somehow, so I need to check on that. So the problem is that this doesn't work for now. It has no influence on the whole schematics. Well, on the whole working yet, because I'm just reading it. And switches only have, for now, influence on the first part. If I look at the second part, the switches just aren't there. So, considering this, these two lines, I2C works. Considering these two lines, yes, let me point out. So these two are I2C, clock and data, and these two lines are connected right here and indicate whether binary counts 1, 0, 1, 2 or 3. So that's all fine. Okay, so I will need to check on the LED later a bit as to why this doesn't work right now. I'm pressing it, but to no result. This is working, and this is working. All wires seem to be connected nicely. So anyway, then it is time to increase the value. Let me see, by the way, if it says button pressed or not. Yeah, it detects button pressed, so that is more than fine. That's alright. That would indicate that there is something here or here not entirely correct. Anyway, let's stop the running of this. And by the way, the way it is connected, this one is for 0, this one is for 1. So now it shows digital 2. Well, digital 0, 1, which is decimal 2. Let me now change the value, adding 1, changing to 5, then this one changing to 4, and am I doing this correctly? because now I am here going to 1, 2, 3, 4. Which is indeed, no, that's not logical. If I want to have all values, I need to go to 7. 3 LEDs make up a total of 7. So that means from 0 smaller than 8. Because the digit 7 is comprised of 3 LEDs, 3 ones. So if I go here, I need to start at 7. That makes more sense. So I have to compile. That goes right. So now let's see if the red LED here, oops, if the red LED right here is working as well. And then I should do something to make clear that your red LED does indeed work. So when it reaches 8, I need to pause for a moment. So let me put a delay of, let's say, 1 second, if that is going to work out anyway. Do I have a delay? No, I have a time sleep. So I need time sleep. And that is then how long? That is a very good question. Let's say 1 second is just like this. Alright, let's check it out. One more compilation. Yep. And by the way, I have here the Raspberry Pi camera again, but once again you won't see the LEDs very properly. Alright, let's run. That's 1, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. But I have a problem because it only counts up. It doesn't count down. Why doesn't it count down? Two, 3, 4, 5, 6, 7, blank. Okay, that reveals that this does not work. Let me stop it. Going up. Y is 5. Would that have anything to do with it? Y is 2, white 1, and 0, eight, 16, 32, etc. Delay is 200. Oh wait, if I have a delay here of 250, then 1 is way too short. So let me indeed increase, oops, not here, here. No, what am I doing? Insert 3 zeros. Recompilation. Go. What happens? 5, 6, 7. Okay, that takes way too long. It is burning at which digit? It is burning at, oh wait, there's one wire in the way. You can't see one element of it. Yeah, now you can see all. And the delay of 1 is way too much. That's a problem. So this means that I have to change this one. Let's change this to 255. No, 250, same as this delay. And now I'm quite curious what will happen. Alright. Go. Oh, and then it helps if you can see something. 5, 6, and 7. Oh, this is not good. This is really not good. Not sure what is happening. Okay. Yeah. So here I am going up to 7. Then I am supposed to sleep. And then I am supposed to go here. But if I look around, then this one, let's copy this one. No. that did work. So somehow here something goes wrong. Question is what? Oh wait, time sleep is, and this is the, what is the difference then between time sleep and delay? That's a good question. If I do change this to delay, another compilation, go. So once more, 3, 4, 5, 6 and 7. Whoa, what happened there? 1, 2, 3, 4, 5, 6 and 7. Well, it does work, but extremely fast. Wow. 2, 3, 4, 5, 6 and 7. Whoa. Okay, so the countdown does work, but I have no idea why it goes so fast. This has a delay of 250. This has a delay of 250. This as well. So what's the difference? This is a curious thing to do. It is now very clear that I should not change this part of the algorithm, which is the same as this part. It does do what it should do. And bit is indeed counting up, counting down. This is counting up and this is counting down. Well, this part that is, this is counting up, this is counting down. Exactly what it should do. This is weird. This is really strange. Why does it go so quickly? And then it turns out that it is quite logical. First of all, going through the algorithm, unending for loop. But that isn't in timing. Then, if it reads the switch positively, 1 second. If it reads the switch falsely, because it's not pressed, 1 second. So 1 second plus 250 milliseconds is, right, 1 second and 250 milliseconds. So that goes relatively slow. Then a delay of 250 milliseconds, quarter of a second, and then here quarter of a second. So of course up goes way slower than down. How do we change that? Well, let me here add a 1 and let's see if that changes the whole thing. Go. And let's see if everything goes according to this plan. 7. And yes, now it's much slower because it is now exactly the same rate as the other one. 3, 4, 5, 6 and 7. 1 pause, and that is 250 milliseconds, and then it is going down and going up again. So yes, that works. Now for that switch right here, that is apparently still, now it works. Can I see it on screen, please? Okay, let's press the button. I can't see it. Okay, let's do this for a moment. Yeah, button pressed. Definitely button pressed below, right here. So I'm holding it, and now it says button pressed. Right, so it does work. But this also means that now my algorithm in theory is very good. Except for the fact that it doesn't do what I intended, because what I intend is to have this done without button pressed, well, let's say button pressed, and this without it, and that takes a bit more. Okay, let's go here. Because that means that this if statement will go here, and all of this, this for loop will go inside this if statement. And then this one will go here, and this for loop will be inside this statement. And this is part of this for loop, so it will all go in this, inside this one. But if that is going to work, is for next time, because time is running out once again. Actually, I said you can't see anything on here. Well, turns out you can here with these 3 LEDs. The only thing is that you can only see these first 2 green LEDs. This one does work, but you have to look right on top of it in order to see burn. And that with the delay of some 2 seconds doesn't make it any easier. 3, and then the 4 you can't even see, so now it will be 7, and then it counts down, but you won't see this one work, so I may have to replace it with the green one that you can see on the side. And as it happens, I do have two green LEDs, so next time I might replace it. Yes. And that's it for today. So the binary up and down counter is working, and next time hopefully the algorithm gets the way I want it, and then I would like to see indeed if this switch does indeed what it is supposed to do. Not that I doubt it, but how the reaction in total will be. This keeps counting, and I have to speed up the counting in order to make everything working nicely. Or things can go wrong. Anyway, thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, leave a comment or suggestion, and you can also follow me on Twitter. Please retweet, like it, leave a comment. You can also follow me on Instagram. Please like it, leave a comment. And it is appreciated if you make a small donation as appreciation for my blog, for my videos. You can also choose to become a patron and have your name mentioned as a supporter. Your name will be mentioned on my website, and depending on your pledge, also with my videos. More information on all social media names and for my website, please see below. That's it. To be continued. Bye bye.